Okay. All right, so for continuity, we want to find the y value first. Where are we checking for continuity at? 0. So the first thing I'm going to look for is f of 0. Look at your graph. Do I have a y value, a closed dot at 0 on the graph? Yes. Now they didn't draw it, but remember, if it's not open, it's closed. So that means this counts as a closed dot. Even though they didn't physically draw the dot for you, unless they mark that it's open, there being a line there means it counts. So my closed dot is at -1. Second thing I'm going to check are my limits from the left and the right as I approach 0. So 0 from the left and then 0 from the right. Okay, look at your graph as I approach 0 from the left. What does it come out to be? What about the right? -1. Are those the same? Okay, then look back at your steps. I had a y value, but if my limit doesn't exist, I don't even go on to check the third step. So at this point, I would say the limit as x approaches 0 doesn't exist, therefore not continuous. Okay, so remember, if any of those steps along the way don't make, then you don't like keep going to the third step. You would just stop there. Okay. All right, turn the page. Lots of review here. This is like the first month of school. Okay, take a look at the next page. Continuous means your graph has to be connected. Okay, you can't have, let's put no, you can't have any jumps. You can't have any holes. And you can't have any vertical asymptotes. And then what did you just say?
Oh, I think that was different.
But your list was what? Cusps and corners. Now think about, if I have a cusp like I do here, is it connected?
Right.
Yes, what it's not is differentiable. So for the next one right here, differentiable, it has to be connected and it has to be smooth. Okay, and when I say smooth, what I mean is none of the things that Mike just listed. No cusps, no corners, and no vertical tangents, or we'll say vertical slopes. Okay, so what differentiable means is that you can draw the tangent line at the graph and you can find the slope of that one. So for a cusp, like I have right here, it's like, how can I draw a line to lay alongside that? On this side, my graph's line would be pointed up, but then on this side, my graph's line would be pointing this way. So the problem is there's no way for you to line a tangent line up on the top of like a little mountain top like that. Now, what if it had looked like this, where it's a smooth turn? What would my slope be at C? At 0. Okay, so C is totally fine, but A is not differentiable, which is the answer to the question, because it has that cusp. So up here, look at it, it says in the graph where F is, where is F continuous, but not differentiable, it would have been. Okay. Any questions on that? Okay. Next 2 questions, your X is going to infinity. Normally, if it were a number, I would just try to plug it in. What do I do if X is going to infinity?
Is this one the check if it's top and bottom has like a bigger exponent?
Yes. Okay, if X is going to infinity, Bobo, Button, Betsy, that's right. Okay, if it's Bobo, that's bigger on top and it goes to 0. If it's Botan, it's bigger on, oops, I wrote that wrong. What should Bobo have been?
Bigger on bottom.
Thank you. Okay, bigger on bottom goes to 0. And then Botan is bigger on top And that means that you don't have a horizontal asymptote or a limit, so you would just put. Okay, then the third option is bed C. Do we remember what that stands for?
They're equal.
Both equal. What do you do with the numbers in the front? Divide coefficient.
Would that be E? Or,
For the none is DNE because you don't have a limit. And the reason that it's Boston is because you learn this rule in pre-cal and they haven't covered limits. So that's why it's not like DNE. It's none because in pre-cal you haven't done it. Okay, so let's do this one first. Look at this fraction first. What's the biggest power on top? X fourth. And then what about on bottom? Then that makes it a bed C. Then I divide the numbers in the front. 5 divided by 3 is 5/3. Very good. Okay, now look at the one right next to it. The only difference is this one is already multiplied out for us. This one's not. So multiply it out yourself and see if it's a Bobo, a Boston, or. So multiply that one out yourself. You don't have to multiply the whole thing, mainly just the highest term. What did you say? Bed C. Okay, so then what is the highest term on top? Okay, what number in front? 2x squared. Okay, and then what about on bottom? 1x squared. And then I think I heard someone say it is a -2. So don't miss this negative here makes that come out to be -2/1, which is going to be our limit, -2. Yeah. Okay, next 4 questions. Your X is approaching a number. So let me put your little cheat sheet back up here. Okay, way back in the day, here are your strategies. Strategy number 1, you're just going to substitute the X value. If that doesn't work, then try factor cancel. Okay, so do those next 4. You can do it. Okay, you only have like 2 weeks left, and then we're just watching movies. Okay, let's go. You can do it. You can do it. Here we go, people. You can check your answers with each other if you want to. Bryce, you okay over here with me today? Can I go get some water? Okay. All right, plug in those next 4.
2 more.
Oh, wow, you remember it. You love it. Okay, I'm gonna give you a few papers, but just don't look at them, okay? What'd you get? If you plug that in, you should get 0/0. So you need to factor cancel to plug in. So how can you factor the top of that?
Oh,
Right.
Yeah.
Then you cross out the ones that are.
You cross out the like terms and then you just plug into what's left over. That's exactly right.
but then we still plug it in, right?
You plug it in after you factor cancel.
Okay.
Yep.
Oh, wait,
No.
wait.
So it doesn't exist, wait, so do we put 9 or 0?
For which one? You shouldn't get 0. So how'd you factor the top?
X plus 2, X plus 3,
Like, okay, and then how'd you factor the bottom?
X plus 5, X plus 2.
So the X plus 2 is crossed out, and then you're plugging in -5.
Then -2 over 0.
No, on the bottom, you plugged in. Hold on, let me come up here.
I think he's right? Yeah, I got -2 over 0.
What did you type on the top?
X
Oh,
plus
the
3.
top is X plus 5, X plus 1. Because remember, what's, you need them to
Oh,
multiply
5,
5 and then add 2.
Oh,
Oh, keep all those. Kyle.
Oh.
Those are all for you.
Wait, it's still gonna be the same.
So if it's a 5 and a 1, then now what's crossing?
X plus 4.
The X plus 5.
Which means now you won't end up with that.
Would I be hungry?
No, definitely not. Nothing to see here. Nothing to see here.
You know, so I think everybody,
GCF. They both have what? Just keep both at all.
I think she handed out some good.
How do you factor number 4? What can you take out of number 4?
X squared.
Okay, and then if I can take an X squared out of the top and the bottom, then what?
Make it easier.
You make it easier, yes, you can cross them out and then just plug in what's left over. Okay, we'll talk about what you just got to say. Just ignore it. No problem. It's already happened. No problem.
No, I don't. Oh.
Okay, so if you need help with 3, there it is factored. Cross these bad boys out, and then you're plugging in -5. So -5 plus 1 on top would give you what? And then -5 plus 2 would give you -3, which means our answer is going to be Z. Okay, next one, we said we're taking out an X squared from the top. Remember, your limit stays in the front. We're just trying to fix it. So if I take an X squared out of the top, what's left in the parentheses? Okay, 5x squared plus what? 8. And then the squared is out though now, right? Okay, then on the bottom, I can take out an X squared. That leaves me with what in the parentheses on bottom? And then remember, the whole point of pulling that X squared out is so that when you cross it out, now you'll be able to plug in 0. So if I plug in 0 on top, what am I going to get? Plus 8. And what about on bottom? -16. 8 over 16 is -1/2. Very good. Okay. Take a look at the next one. Okay, this one ends up being a little bit weird. We went over this long ago, but let's see what we remember. Can I plug in 2 right now? No, because I end up with 0 on top and 0 on bottom. Not going to work. So how can I factor the top of this? Okay, plus 2 and -2. Can I then cross out x minus 2 and 2 minus x? Is that a thing? No. So what can I do to the bottom to reverse the order of subtraction so that the top and the bottom can't cross out? Because right now these can't cross out. Take out a negative. So here's what you're going to do. Look, keep the top the same. X plus 2 and x minus 2. But then on the bottom, you're going to GCF a -1 to the front. Now, here's why that helps. If I pull the -1 to the front, then now what's the sign on my X? My X would turn positive and my 2 would have to turn into a negative. Does that make sense? So anytime that your terms are almost crossing out, but just the subtraction is backwards, pull a -1 out, and now we can cross these out. Then what was X approaching?
2.
So then I plug my 2 in right here. 2 plus 2 is 4. Is that my answer? 4 over what? It'd be 2 plus 2 over that extra -1 means it's negative. Okay, so now see if you can do the next one. You need numbers that multiply to -6 and that add to +1 to factor the top. Multiply to -6 and add to +1. Okay, what could we pick? Okay, 3 and 2 plus 3 minus 2. Okay, then on the bottom, it's not x minus 2, it's 2 minus x. So what do we pull out? -1, and now it's an x minus. Okay, then what are we plugging in for our x? So what are we gonna get on top? What are we gonna get on bottom? Okay, so 5 divided by -1 is negative. Questions on that? Okay, I'll just tell you about the 3 packets.
I'm sure she just passed out the wrong.
Okay, so here's the deal. Okay, obviously, we're done with Delta Math homework. Okay, so those 3 packets, I'm gonna post it, answer keys onto Google Classroom. Okay, but the point is for you to review for the AP exam. So if you just copy down the answer key, I'll never know, but you'll know because you will be prepared for the AP test. So I'm gonna count all 3 of those as quiz grades, but you're gonna have the answer key online. So just work through them. If you get questions, you can pull up the answer key or you can ask me. They're gonna be graded completion because you have the answer key online already. And then you just have like, I'm passing them out today because everybody's like, seems to be out.
So are we not gonna be doing this in class?
If you have a question on one, we can do it in class, but mainly all of our assignments in class will just be like reviewing old stuff like we're doing today.
And if you go back and plug in my.
Yes, did you email me?
No, I told you this, you said you were gonna do it.
I always say I'm just email. I'll email myself. Okay, turn the page. Ready? So no stress. It's not to stress you out. Okay, it's just to give you resources to be able to review so that you can be prepared. Okay, but if you never do it, I'll never know. Okay, because you'll have the answer key already. Okay. All right, so next little set here. Other than factor cancel, we learned one other rule. You can see it right here. Okay, for L'Hopital's rule, if you get 0 over 0, which is called the indeterminate form. Do you remember we said that's when you do more? Okay. So ways you can do more, you can factor cancel, or you can do L'Hopital's rule. So L'Hopital's rule says if you have a limit f over g and you're getting 0 over 0, you can retry the limit with the derivatives of those functions. So you take the derivative of the top and then the derivative. Now, you are not doing a giant quotient. You're treating the top as its own function and then you're treating the bottom as its own function. Okay. So let's take a look at number 1. Okay, if I get 0 over 0, I can do L'Hopital's rule. 2 cubed minus 8, is that 0? What about 2 minus 2? 0, then I know that I can do L'Hopital's rule. You can abbreviate it L'H, you don't have to write out the whole. And then remember, you're going to redo the limit. X is still approaching 2, but you're going to take the derivative of the top and the bottom. What is the derivative of the top? 3x squared. What about the minus 8? What happens? Goes away because it's a what? Constant. Okay, on the bottom, x minus 2 derivative is just a 1. And then I take my x approaching 2, pop it in there. 2 squared is 4 times 3 is 12. Okay, now one other thing. Could you have done this by factor cancel? If you remember your pre-cal, this is a difference of cubes. There is a formula for that. But yeah, if you don't remember it, did you say you know?
Oh, no, I was like the B and A thing.
It was with
The
the
B
A
and
and B.
thing.
Yeah. So it's a cubed minus b cubed is a minus b, a squared plus ab plus b squared. Okay, but unless you remember that, okay, then you would be screwed unless you know L'Hopital's rule. So I would never do that by difference or sum of cubes because probably you don't remember the formula anyway, right? Okay, so go to number 2. Plug in your 0. What's cosine of 0? -1. That'd be 1 minus 1, which would be 0. On bottom, plug in your 6, you get 0 over 0. Then we know we're ready to do more. Okay, what is the derivative of cosine x minus 1 across the top? Negative sine x. Do I keep the -1?
No. Here's the constant.
Good. And then on bottom, 6x goes to just say 6, and then I'm plugging in 0. What's the sine of 0?
0.
And then I got 0 over 6. Is that de-ending?
Yeah, it's okay.
It's okay, means it goes to 0. So think about if you have 0, you can divide that by whatever, and you're gonna still get 0. The only thing 0 can't divide by is another 0, okay? So up here at the top, I'm gonna put, remember, it's okay to get 0 on the top, but no, you can't get 0 on the bottom, you would put the ending for that, okay? And then like we said, if it's 0 over 0, that's when you do more. Okay, so see if you can do the bottom half of that page. You can do it. Yes, you can. You do. So what would the derivative of sine of 5x be?
Wait, you'd be what?
It'd be sine goes to cosine, keep the 5x the same, but then you have to times by the derivative of 5x. So yeah, you just times by an extra 5. I go in front with that. Good job. Good job. Yeah. Is it 0? So then that's all you need, right? At the top is a number, at the bottom is 0. Can you fix it with a little example? Nope. So what would you get? Over 0. Then what's your answer? Up here. 0's on top, you pick 0. If it's a number over 0, even if it's e, that's still a number. You know what I mean? What's the derivative of e to the x?
Yeah.
What about ln x?
Alright.
1 over x. Good job.
Alright.
The 0 on top?
Right.
Is it? You plug in a 3.
Oh.
It's either the 3 or
Right.
0.
No.
Then you can't use L'Hopital's rule. You just have to plug in.
Okay.
Are you watching, which one? That one should be positive though. Oh, no, you're right. Hold on. No, sine goes to cosine. No, negative. Because think about, you're already at the top of the snow coast. I think you're thinking about if you did an antiderivative and you were going up, it'd end up negative. But for a derivative, you're going down the snow coast. Yeah. Yeah.
What? No. Oh.
Good.
Oh, yeah. I can. So it is positive on first.
Uh-huh. Okay, so number 3, what was our final answer? Let's go with, Isle, what'd you get? 5/3. And then what about number 4? Let's go with Jackson, what'd you get? Good? Okay, number 5. When you plug in 3, what do you get on top? e to the 3. Even though you might not know what number that is it a 0? No. And then on bottom, I plug in 3 minus 3. So I get e cubed over 0. That's not indeterminate form. It has to be a 0 in both spots. So what is our conclusion from this? DNE, very good. And remember, the DNE comes from the fact that if there's a divide by 0 in the bottom that doesn't cancel out, that means you have a vertical asymptote. Okay. Number 6. It is e to the 3. Good. Because you plug in your 3 on top, you get e cubed minus e cubed, that's 0. And then you get 3 minus 3, that's 0. And then you're like, okay, then I can fix this using L'Hopital's rule. What is the derivative for the top when I retry the limit? E to the x, the derivative is e to the x. What about the minus e cubed? And the derivative of a constant is 0. Okay, very good. The other class kind of had trouble with that. Okay, so if it's e to the x, the derivative is e to x. But if it's e to the 3, that's a number, derivative goes to 0. Okay, then on bottom, x goes to a 1. Then you plug in your 3 and you just get e cubed. Okay, which is somewhere between like 7 point something. Okay, go to number 7. Plug in 0 on top. What do you get in the 2x squared?
0.
0. What do you get on the bottom if you do e to the 0 minus 1 minus 0? So this is a 1, minus 1 is, and then minus 0. So this is an indeterminate form. So take your derivative of the top and the bottom and then try to limit again. What happens? So 2x squared goes to, and then on the bottom, e to the x stays in e to the x. What about the minus 1? It's a constant. Okay, and then minus 1 from the e to the, from the minus x. Okay, then I plug in 0. What do I get on top? 4 times 0 is 0. E to the 0 is 1. Minus 1 gives me. Hey, remember though, L'Hopital's rule, you keep doing it until you fix it. One of the parts of the function has to not be 0. So let's take the derivative again. What do I get for the derivative on top? Just a 4. And then what happens with e to the x minus 1? Stays the same, except for the minus 1 will go to 0. And now from there, I'm going to get a conclusion. When I plug in a 0, the top stays a 4, but the bottom is an e to the 0, which is the same as 4 over 1, which is 4. So remember, you can repeat L'Hopital's rule. The most I've ever seen it on the AP test was 3 times, but you could do it as many times as you want. Good? All right, number 8, do we get 0 over 0?
Yes.
Because we have ln4 minus ln4, and then 4 minus 4, both 0. Okay, so let's retry our limit with the derivatives. What is the derivative of ln x? 1 over x. Okay, now ln of 4, is that a function or a constant? That's a constant. What's the derivative of a constant? Okay, that's going to go to 0. So remember, if it doesn't have an x in it, that doesn't count as a function. That's a constant, then the derivative goes to 0. Okay, on the bottom, what's my derivative? X minus 4? Just a 1. And then I plug in my x approaching 4, and what do we get? 1/4 over 1, which, you know, all good? All right. We will get to the bottom of the next page and then we'll take a little break. Okay. All right, almost always when L'Hopital's rule is on the AP test, it's in the multiple choice. Okay, but they have put it on the free response once. So we're just going to kind of look at how you should write it out. So the first thing is you should never put 0 over 0 in the free response. Okay, the reason why is that you're not allowed to divide 0 by 0. So if you put that, they're gonna take off a point and it cancels out all the work that you do correct. So if that were to happen on the AP test, you would just wanna find the top and bottom limit separately, where you're saying like the limit of the top, oh, that's 0. The limit of the bottom, oh, that's 0. Okay, so here's what I mean by that. Take a look at the first one. If this is a free response, I would find the limit as x approaches 2 for the top, 3x minus 6. And then I'm going to find the limit as x approaches 2 on the bottom of 2f of 2x plus 2x. Okay, but you don't want to show this 0 over 0 step. So to make sure you don't do that, just do the top and the bottom step. So let's plug in 2 first. What's 3 times 2? And 6 minus 6 is 0. Okay, for the second one, we're plugging in our x approaching 2. So I have 2 times f of 2 times 2. What will that be in here if I plug in a 2?
4.
F of 4. And then plus 2 times 2 is 4. Where can I find f of 4? What did they give us? Okay, they gave us this little chart over here, so I'd come down to 4, my F column is an 8. So then I have 2 times 8 plus 4. 2 times 8 is 16, 16 plus 4 is 20. Did they both come out to 0? And this is not L'Hopital's rule. Okay, it was set up like it would be L'Hopital's rule, but I ended up getting 0 over 4. Then what's my conclusion? Or I'm sorry, 0 over 20. Then what's my conclusion? Oh, 0. Remember, it's okay to get 0 on the top. You just can't get it on the bottom. Okay, now I accidentally copied the wrong page above the thing. So I think I had fixed this on another page. Hold on, give me like 1 second so that I can remember what it was. Okay. Okay, hopefully that works. Rewrite your limit. I accidentally grabbed the wrong table when I copied the worksheet. Or made worksheet. Okay, so make it f of 3x minus 6x over 4x minus 4, and then we're going to change the x approaching from a 2 to a 1. That way it goes with the chart. Okay, so if it's multiple choice, nobody cares if you plug it in all together, but if it's free response, you're going to separate the top and bottom. So let's do the top first. We want the limit as x approaches 1 of your f of 3x minus 6x. Then we're going to find the limit as x approaches 1 of 4x minus 4. Okay. From there, plug into the first one. What am I going to find from my chart if I plug in a 1? F of 3. What's f of 3? 6 minus 6 times 1 is a minus 6, which means I get 0. So the top came out to 0. Now we have to check the bottom. plug in your x approaching 1. What do we end up with? 4 minus, which is 0. So did I get the indeterminate form? Yes, but we didn't put 0 over 0 if it's first response. Okay, then from there, all that you would do is you would come up here and you would say, by L'Hopital's rule, I can retry my limit again. I'm going to take the derivative of the top and the bottom separately. What rule will I need to take the derivative of this top? Chain rule. Good. What's the derivative of f? F prime, keep the 3x the same, and then times by 3 in the front. And then minus 6x, what's the derivative? 6. Okay, on the bottom, we're plugging in the derivative of 4x minus 4. What's that? Just a 4. And now we're ready to plug. Okay. So we're plugging in a 1 on top. I'm going to have 3 times f prime of what? F prime of 3, because I'm plugging in a 1 to the 3x minus 6 over 4. And then what is f prime of 3? Negative 4. Then I have 3 times negative 4 minus 6, which is negative 12 minus 6. Negative 18 over 4, can that reduce? Negative 9 over 2. Okay, but remember, the big no-no is if it happens to be on free response, no 0 over 0. Otherwise, they will give you your credit, even though really you know what to do. Okay? All right, one more left, and we're taking a little break. Says identify the vertical asymptotes for x squared plus 3x minus 4 over x squared plus x minus 2. How do we find vertical asymptotes? This is really a pre-cal question.
Factor the top.
Yeah, and bottom, and then look for what crosses out, right? Oh, okay, yeah. So we have to cross out, and then the ones left over. Yeah. Okay, so back to that for me. What are we gonna get on top? Okay, x with a plus 1 and a minus 4? Yes, and a minus 1. Okay, what about on bottom? Have to multiply to negative 2, but add to a positive 1x in the middle. Okay, what's going to cross out? And what feature does that make in the graph? That's a hole. So there is a hole in the graph at x equals 1. Now, quick clarification here. For a hole, does the limit exist?
Yes.
If it's a hole, does the limit exist? Yeah. Limit still exists. And if you think about it, it makes sense because when you factor cancel, it's 15. And then when you plug in, you'll be able to get an answer. Okay, where do the vertical asymptotes come from? Holes cancel. They come from the bottom. So if x plus 2 is left on bottom, that makes a vertical asymptote where? At negative 2. And then what about the limit at a vertical asymptote? Does it exist? No. Technically, if it were asymptoting like both up, you could put that it equals infinity. Or if it was asymptoting down, you could put negative infinity. But either way, it just technically doesn't exist. It's not approaching specific. Okay, so we would pick which one? B, yeah. Okay, now one more thing I want to remind you of. Okay, a hole is what we call it in pre-cal. That's not the calculus term that they're going to use. Okay, so right here for a hole, that's what we call it in pre-cal. You guys are going to see it as a removable discontinuity. Okay, so remember, they're not gonna call it a whole. If you called it a whole on a true response, I don't know why you have to say that, but they might still give you credit, but they're gonna call it this. So remember, for a removable discontinuity, it isn't connected, but the limit does exist, because you're just saying, like, if I remove that point, the graph would have been gone. Okay? All right, so let me just give you an idea. We're gonna take a 5-minute break. Okay, but all that we have to get through are the next 3, and then the top one on the next page. So we really only have 4 questions left. Okay, and then we're gonna stop right when we get to this free response question. Okay, so if you have to go to the bathroom, go get some water, have a little snack. Okay, you can do it. Go ahead. Take the bathroom talk, please. Being passed off. No, his teacher did. He's really bad at trombone stuff. But he's already decided that he's gonna quit next year, so he's lost his little motivation. Okay, I'm gonna fix your thing. What did you say you need me to do? Reset or just change grades? Okay. Okay.
Actually, there are more questions I didn't do. I wouldn't do that.
I'll go ahead and still update them now, and then if you do more, just let me know. They do. I know. Well, it depends. If it's multiple choice, then they won't take off for it. It's just the writing portion that, like, technically, if you look at the way the theorem's written
At the top here. If you look at the actual theorem, they don't put 0. This is what it says. If your functions f and g both have limits equal to 0, then the limit equals this. So this is the actual theorem, is it shows it separately. And then. So that's your technical theorem. This is what, we kind of added in, but the theorem is that. So it's kind of like with continuity, how you have to follow those exact steps. Since this is a theorem, even though it's followed L'Hopital's rule, it still has that same sort of like rigid structure that you have to follow. Okay. So homework 8, you need a reset. And then homework 7, maybe. You need a reset. And then homework 5, 1 reset. You're still working on that one though, I'm guessing. Uh-huh.
Oh, no.
Is that gonna be your dropped grade?
Yeah.
Okay, and then homework 2, do you want me to reset the? Or you just have to finish, you don't actually even need a reset, you just have to finish it if you want to. You already have an A though, you have a 93 on it. Oh, and then y'all, if you bring me a box of tissues, I'll drop a 0. Okay. Because everybody, yes, if you bring a box of tissues, I'll drop a 0. You can only bring 1. Thank you for asking though. And then remember that if you do those 3 AP reviews, they're all quiz grades. You'd be passing even if you just only did those 3. So, because they're major grades and your homeworks are all minor grades. See, good. Correct. as long as you do those 3 reviews. And I'll put I already have the keys done. I just have to put them online. But the point is that you do it and then just check. You know? Good. Yes. You wouldn't have to. It would be good practice. But if you are only looking to pass, then if you work through each of those 3 homeworks with the key, you would be passing just based on that. Okay, my homework 8. Got it. Just by the AP test, which is in like weeks. So 8, 7, 6, 700.
And then are the behaviors that you've already given us, are those progress too?
Are you talking about the ones after school? Those are to replace your final. Those don't go in this quarter. So if you do them, cool. If you don't do them, it's fine. Homework 5. Nine. All right, we ready to finish? Almost there. Okay. Let's skip this one for right now. We'll come back to it. Look at the second one. Okay, if X is approaching a number, what do you do with the number? Just plug it in, yeah? Now, notice what kind of trig is this? Are these regular sine and cosines and tangents? Okay, these are inverses. Very good. So I'm going to have the inverse tan of 1 over the inverse sine of 1 plus 1. So let's just do a real quick refresher. Normally for trig, you're going to get your angle as your x, and then you're going to give the number on the unit circle as your y. What will the ordered pair be if it's inverse trig? What will the ordered pair be for inverse trig? Okay, yeah, so they're going to give you the number, and then you're going to give them the theta. So basically, if we want inverse tan or inverse sine of 1, we're looking for the finger or the angle where you would get 1 as your answer. Does that make sense? So think about in your head what inverse sine of 1 would be. I would want all my fingers on the sine side of the hand. Where are your sine fingers? Above or below the bend? Sine's below, that means I want all of them below, which means I'm folding down the thumb, which is what angle? Yep, plus 1 over. Okay, and then on top, let's do tan. Tan is sine divided by cosine. So how could tan come out to be 1? What would have to happen? They would have to be the same. Otherwise, sine divided by cosine can't be 1 if they're not the same. So which finger do you have the same number of? Which one? High fourths. There you go. Okay, now I want you to take a second and see if you can match. This is correct, but try to match it to one of these. So I'm going to give you a little hint. Your first step should be to get a common denominator down here. Well, let's just change the 1. What could 1 be? 2 over 2. So now I would have this, yeah. I'd have pi over 2
plus 2 over 2, which means really, what do I have down there? Make sure you're adding. No, so it'd be pi plus 2 over 2. You know what I mean? Okay, now, why do I want that as one fraction? Because now if I'm dividing pi fourths by another fraction, now that this is a one fraction down here, what can I do? Multiply by their reciprocal, yeah. Okay, so you're gonna just leave the top the same, get a common denominator on the bottom, and then you can flip the bottom and multiply. So did y'all ever call it copy, change, flip?
Keep changing.
Oh, keep, change, flip. Okay, so keep the top as pi fourths. Change the divide to multiply and then flip the bottom. So it'd be 2 over pi plus 2. Question, can I cross out the pi? No, that's not a thing. Okay, so what we're gonna have to do instead is multiply. So I have pi times 2 is 2 pi. And then on the bottom, I'm gonna have 4 times pi plus 2. And then I'm not even gonna times it in because what do I see can happen out here in the front? What can those rows divide by? 2. So 2 pi divided by 2 would just be pi. And then 4 divided by 2 would just be 2. So if you pull that 4 out to the front, or you keep it out in the front, then you can produce this. So what answer would we want there? E. Okay, one right below that, it asks you to find the limit as x approaches 3. Look at your graph. Look at it. Yep, this is called the step function. I'm sure you don't care about that. Okay, but there's 3. What's the limit as x approaches 3? Okay, so on this side it's 0. On this side it's -1. Then what is this limit? D. And if it made you justify, you would say, just for extra practice, because the limit as x approaches 3 from the left, that's your little negative sign, is equal to what? What was my left side limit? -1. And the limit as x approaches 3 from the right of f of x is 0. Okay, so you should know how to do those justifications. Remember, your limit only exists if the sides are the same. So if you're saying it doesn't exist, you should know how to prove it. All good? Okay, take a second, look at the one at the top of the page. 2 questions left, almost done. Plug in what x is approaching. See what happens. So last question on this page right here. What am I gonna get? That's a problem. I end up right here with the 1 over 0. Very good. Now, technically, 1 over 0 by itself is a DNE. But if I plug 0 in to the whole thing, where is there also going to be a 0? Okay, there'll be 1 in the e to the x and 1 on the outside. So this is technically what I have. Right? So think about, if I had times this out, I have a 0 on the bottom, but do I also have a 0 on the top?
Yeah.
What about this one?
Oh, yeah.
So that counts as an indeterminate form. So I have a divide by 0 here. I have a times by 0 here. So what that means is this could be fixable. Now, factor cancel won't work. If I did L'Hopital's rule, I'd have to do a product, and I don't want to do that. So what could I do instead with that x outside of the parentheses to make it not a product anymore? Multiply it in. Very good. So let's do a simplify on this. Technically, we're not using L'Hopital's rule, but I'm going to do x times e to the x. And then x times 1 over x. And what's going to happen in that second term that's gonna fix the whole problem.
So,
Well, it would have been 0 over 0, but now that I have an x times 1 over x, what's gonna happen? They're gonna just cancel out, right? Because think about it, if you have the x on top and an x on bottom, those cancel each other out, and now your equation is just x e to the x plus 1. So this ends up simplifying or canceling out. I don't know why I wrote that twice. Okay, but you end up simplifying that x over x. Now it's just a plus 1, and now the problem's solved. Okay, and then from there, what was x approaching? 0. So then plug in your 0 to that, what would you get? 0 e to the 0 plus 1.
1, 1.
So that would come out to 0, but then 0 plus 1 would be 1. Make sense? So if you look back at your little study sheet, remember, you try to plug it in if you can. You try factor cancel if you can, and then simplify. Okay, there are a lot of different ways to simplify, but multiplying would be one. Okay, last question for today. Turn the page. You have a piecewise function. What is the breakpoint of this function? Okay, pi is the breakpoint. And then they say, for what value of k will the function be continuous? What do I do if I want to make the function continuous? Set them equal for what x? Pi. So you're going to set your left equal to your right side, and then you're going to plug in the breakpoints. Set your left equal to your right, and then plug in the breakpoints. So I would do the sine of 2x equal to 2x plus k. K is a constant that I don't know, but then I know my x is going to be pi. Okay. And then we're just plugging that in. So pi is going to go here. Now it's the sine of 2 pi equals, plug it in here, that'd be a 2 times pi plus k. And then what angle is 2 pi the same as on the unit circle? 360, which is the same as 0. So that means this is really just the sine of 0. What is the sine of 0?
0.
So then 0 equals 2 pi plus k, which means what's k?
2 pi. Oh, negative 2 pi.
Negative 2 pi. Which would be k. Overall, make sense? Okay, so as of today, if you look at your 3 AP reviews, okay, you have about 20 minutes. If you want to work on one, I'd work on the one that says limits, because we just covered one. And then next class, we'll work on derivatives. And then you can work on the one that says derivatives. And then the next class after that, we'll do integrals. And then you'll be able to work on it. Okay, there is an AP review after school. Is anybody gonna come? Maybe. Or I'll just record it. But maybe you can come if you want. Today's accumulation. And then have we all been able to find the video links and stuff fine?
I keep forgetting to do it, so
Uh-huh. Yeah. Oh, Paloma, will you take the bathroom pass? You want